This video is a walkthrough of a non-calculator paper, paper 1H, from practice tests set 3 for the new Edexcel GCSE grades 1 to 9. So no calculator allowed here. First question, the equation of a straight line is y equals 4x plus 7. Write down the gradient of the line. Well, this appears in the form y equals something times x mx plus c, and this is always the gradient. The thing that goes with the x, the multiple of x, is always the gradient. So that's 4 in this case. Write down the y-intercept of the line. That's the constant number at the end. So that is 7. Work out 3 1/8 minus 1 2/3. If it was an addition, I think I would deal with the whole numbers and the fraction bits separately, but as it's a subtraction, I'm going to do them all together. In order to subtract these, I need to have the same denominator. I'm first of all going to turn them into improper fractions. So 3/8 are 24, that is 25/8, minus a whole, that's 3 4 5/3, 3 times 1 plus 2, minus 5/3, and now I'm going to turn these both into 24ths. So this one needs to be multiplied by 3 over 3, so that is 75 24ths, minus, and this one's multiplied by 8 over 8, so 5/8 are 40, and 3/8 are 24. 75 minus 40 is 35 24ths, because the denominators are now the same. So 35 over 24. 24 goes into 35 once with a remainder of 11, so that is 1 and 11 24ths. That's my answer there. Question 3. Here are the ingredients needed to make 8 shortbread biscuits. 120 grams of butter, 60 grams of caster sugar, and 180 grams of flour. Tarek is going to make some shortbread biscuits. He has the following ingredients: 330 grams of butter, 200 grams of caster sugar, and 450 grams of flour. Work out the greatest number of shortbread biscuits that Tarek can make with his ingredients. You must show all your working. When I look at this, first thing is to see which is the limiting ingredient, because one of these is going to limit how many he can make. And I'm just going to check if I times 3, that gives me 360 grams of butter. 60 times 3 is 180 grams of sugar, and 180 times 3, that is 180 plus 180 plus 180, 540. So sugar, yes, that's fine. I've got 180 grams of sugar. Butter, not quite. And 540 grams, I haven't got anything like that amount of flour. So flour is going to be the limiting factor here. My times 3 was just an estimate, just a way to get started with this problem. So I'm going to see how many biscuits he can make with 450 grams of flour, because that's the limiting factor. So 180 grams of flour is 8 biscuits. Let's double that to begin with, so that's 360 grams of flour makes 16 biscuits. And if I can add 90 to that again, which I can, that makes 450 grams of flour. And that is half of 180, so that's another 4 biscuits, so that's 20 biscuits overall. And I can check, will I be able to, is there enough butter for 20 biscuits? That would be 2.5 lots of 120, so 120 plus 120 plus 60 of butter, that gives me 300 grams of butter, which I've got, and I know I've got enough sugar from, well, 3 60s are 2.5 60s, sorry, Sugar, 2.5 60s are 60, 60, 30. That's 150 of sugar, which I've got. And 450 grams of flour. So final answer, 20 biscuits. Question 4. Rail tickets and cheap trains are two websites selling train tickets. Each of the websites adds a credit charge card and a booking fee to the ticket price. For rail tickets, credit card charge is 2.25% of the ticket price, and the booking fee is 80 pence. Cheap trains, the credit card charge is 1.5% of the ticket price, and the booking fee is £1.90. Nadia wants to buy a train ticket. The ticket price is £60 on each website. Nadia will pay by credit card, so she's going to be charged both of these charges for credit card in either website. Will it be cheaper for Nadia to pay the train ticket from rail tickets or from cheap trains? So we're going to need to work out the total cost here. We got the £60 ticket. I'm going to keep this division going through so that I can work on rail tickets here and cheap trains here. So £60 is the starting price, and I need 2.25% of that. So if I work out 1% and then another 1% and 0.25%, that will give me 2.25%. So 1% of £60 is 60 pence, £0.60. So 2% is £1.20, and 0.25%, which is the extra bit I have to work out, that's a quarter of this 60p, so that's 15p. So 2.25% is £1.20 plus the 15, £1.35. And she's got a booking fee of 80 pence as well. So this ends up being 60 plus £1.35 plus 80. Which gives me 5, 8, 9, 10, 11, 61, 62. £62.15 is the total for this one. Cheap trains, go back to the information here, we've got 1.5% of the ticket price, so £60, again 1% is 60p. And 0.5% is 30p. So that is a charge of 1.5%, it's 90p. Booking fee £1.90, so the total price for this ticket is £60 plus the £1.90 booking fee plus the 90p charged as a percentage for the credit card. So adding those together, got 0, 8, 2, £62.80. So cheaper for Nadia to buy the train ticket from this one. So again, because my statement is going to be based on which of these two is greater, I'm just going to write down that I've realized, and this is purely for the examiner, this statement here shows that I've made a decision that £62.15 is less, and therefore rail tickets is cheaper ticket. A cheaper website for this particular ticket. Just check that this answered the question, will it be cheaper for Nadia to buy the train ticket from rail tickets or from cheap trains? And I have answered the question there. Question 5. The table gives information about the lengths of the branches on a bush. Draw a frequency polygon to show this information. So in this question, with a frequency polygon, I need to give the frequency, which is labelled on the left-hand side. I need to plot that at the midpoints of each of these classes. So midpoint of 0 to 10 is 5, midpoint of 10 to 20 is 15, midpoint of 20 to 30 is 25, and each of those intervals as we go along is a interval of 10, class width of 10. So I'm just going to plot at 5, I'm going to plot 20. At 15, I plot 12, which is here, being careful of the scale. 12 is there. Each line counts for 1 unit in this case. 8 at 35. Oh no, I've got to do 10 at 25. 8 at 35. 5, 6, 7, 8. 6 at 45. And 0 at 55. And then connect each of these with a straight line. And that's the frequency polygon. Work out the total number of branches on the bush. I'm going to have to go back to the table. Total number of branches on the bush is adding all of these up. So 20 plus 12. I'm going to do a cumulative frequency as I go. So 20 plus 12 is 32. 32 plus 10 is 42. Plus 8 is 50. Plus 6 is 56, and plus 0 is still 56. So total number of branches on the bush is 56. Work out the modal class interval. Modal means the mode, the most common. So the most common class interval was 0 to 10, because there are 20 in here, and 20 is the highest frequency of any of the class intervals. So 0 to 10 is my answer. Just check the inequalities go in the right places. Greater than or equal to in there. Question 6. Here are 3 circles, A, B and C. Area of circle A is 200 centimeters squared. The area of circle B is 10% larger than the area of circle A, and the area of circle C is 10% larger than the area of circle B. How much larger is the area of circle C than the area of circle A? So, an increase of 10%, 200 plus 10% of 200, which is 20, is 220, so that's circle B. Then 10% larger than the area of circle B, that is 220, circle B, plus 10% of that, which is 22, and that is 242 centimeters squared. So how much bigger is the larger is the area of circle C than the area of circle A? 242 minus 200 is 42, and that's how much larger circle C is than circle A is in centimeters squared. Question 7. Expand and simplify. So this first bracket, I multiply x by 2 and I multiply the 3y by 2. Second bracket, I multiply the x by 4 and I multiply the minus y by 4 as well. And then simplify. 2x plus 4x is 6x. 6y minus 4y is plus 2y. Factorize completely. That means take out all common factors. I can get p out of both expressions, and I can't get 8 out of both, but I can get 4 out of both expressions. So 4p is going to be my factor of both. I have to multiply that by 2 to get 8p, and I have to multiply it by minus 3q in order to end up with minus 12pq there. So that's my answer for that one. If I'd factorized just by taking the 4 out, or just by taking the p out and forgetting the numbers, that would not have answered the question. And just to make sure with that, 2 marks because I've factorized both out correctly. Question 8, the diagram shows a triangle. As soon as I see a picture of a triangle, I think 3 corners are going to add up to 180 degrees. It says all the angles are measured in degrees. Show that the triangle is isosceles. In order for this to be true, I am going to have to work out which of these are equal angles. At the moment, I can't tell which sides are meant to be the same, whether it's this side and this side, or that side and this side, or the 2 top sides. So I'm going to need to work out x. Now I can do that by writing an equation. So if I add all of these together, I'm going to get 180 degrees. So that's my first equation to write. And then I can collect like terms. So that's the 3 angles added together. Collecting like terms, 5x plus 4x is 9x, plus 6x is 15x. And then adding the numbers together, 2 plus 8 is 10, minus 10 is 0. So that's 15x equals 180. And divide both sides by 15. 15 goes into 180. I can check by doing a long division. 15 goes into 18 once. Well, this is not long division, but bus stop method. With a remainder of 3, and 15 goes into 30 twice. So 12 15s are 30. So that leaves me with x equals 12. 12 15s are 180. X equals 12. So if x equals 12, I need to know what each of these angles equal. So 4 times 12 plus 8. So that's 48 plus 8, which is 56 degrees. This one, 6 12s minus 10. So that's 72 minus 10, which is 62 degrees. And 5x plus 2 is 60 plus 2, 62 degrees. Because this is a show that question, I should show my working for each of those calculations. I found that these two are isosceles, these two are the same, and therefore it must be isosceles. So to show my working for that, I'm going to say 5x plus 2 equals 5 times 12 plus 2 equals 62 degrees. And 6x minus 10 equals 6 times 12 minus 10 equals 62 degrees. So 2 angles are equal, and the triangle is therefore isosceles. And of course the reason why the drawing is confusing is that if the 2 angles are given are 62 degrees, then the remaining angle is 56 degrees. These are very close to being the same angle, so these are very close to being the same sides. It's close to being an equilateral triangle, but it's a couple of degrees off that. 9a, find the highest common factor of 30 and 42. So to make sure I get the highest one, I'm going to list all the factor pairs of 30. 1 and 30, 2 and 15, 3 and 10, 4 doesn't go in, 5 goes in 6 times, and now I've found all of the factors of 30. With 42, I've got 1 and 42, 2 and 21, 3 goes into 42 14 times. 4 doesn't go in, because 4 goes into 40. 5 doesn't go in. 6 goes in 7 times. And now I've again found the full loop of that. So the highest number that appears in both lists is 6. So my highest common factor of 30 and 42 is 6. Find the lowest common multiple of 30 and 45. I can list my multiples of 30, 60, 90. Already I can see that 90 is a multiple of 45 because I know that it goes 45, 90. So my lowest common multiple of 30 and 45 is 90. Question 10. The diagram shows a solid prism made from metal. The cross-section of the prism is a trapezium, which we can see here. The parallel sides of the trapezium are 8 and 12 centimeters, and the height of the trapezium is 6 centimeters. The length of the prism is 20 centimeters, and the density of the metal is 5 grams per centimeter cubed. Calculate the mass of the prism, giving your answer in kilograms. We've got 2 different things we need to do here. Well, 3, in fact. Firstly, we need to find the volume. Density, the formula for density is mass over volume. And we can tell that from the grams, a mass measurement, over centimeter cubed, a volume measurement. So in order to find the volume, I need to find the area of this trapezium and multiply it by the depth of the prism. So formula for the area of a trapezium, we take the parallel sides, add them together and divide by 2. So area of trapezium equals 8 plus 12 over 2 times by the height, which is 6. 8 plus 12 over 2 is 10. That's 20 over 2 is 10. Times 6 is 60 centimeters squared. Volume of prism is 60, the area of the cross-section here, times by the length of the prism, times by 20 centimeters, which equals 2 6s are 12, 1,200 centimeters cubed, making sure that I do the 2 times 60, which is 120, and then multiply that by 10 again, because it's multiplied by 20. So 1,200 centimeter cubed. Density is mass over volume, and I need to find the mass of the prism. So if density is mass over volume, if I multiply both sides by volume, I get mass equals density times by volume. And I can see that also by using one of those triangles. Density, mass, volume. If I'm looking for the mass, then I'll cover up the m and I got d times v. Mass is density times volume, so mass equals 5 grams per centimeter cubed. This is in centimeter cubed and that's in centimeter cubed, so I've got 5 times 1,200, and that equals 5 12s are 60, but I have to make sure I get the right number of zeros on the end. 5 12s are 60, and then 2 zeros added. And that makes sense. Right kind of amount. And 6,000 grams is the same as 6 kilograms. Divide by 1,000 to change from grams to kilograms. Some indices questions here. Question 11. Write down the value of 25 to the power of 0. Anything to the power of 0 is 1. And that's just a rule you have to know. You can think of it as 25 over 25. That's 1. Write down the value of 49 to the power of minus a half. The first thing I should do here is deal with the minus sign. So the minus sign means that this is 1 over 49 to the power of a half. And 49 to the power of a half is saying square root of 49. which is 7, so 1 over 7 is my answer. Write as a power of 2 4 times 8 over 16 cubed. So first of all, I can write these as powers of 16. Might be the easiest way to get rid of some of the powers here. So 4 times 8 is 32 over 16 cubed. That is the same as... I could potentially, in fact, what I'm going to do here is turn everything into powers of 2 using indices. So this original calculation, 4 times 8 over 16 cubed, is the same as, well, 4 is, if we're thinking about powers of 2, 4 is 2 squared, 8 is 2 cubed, and 16 is 2 to the power of 4, which is being cubed. So I've replaced that 16 with a 2 to the power of 4, and that equals 2 to the power of 2 plus 3, 5, because I add the indices when I'm multiplying the same base number. 2 to the power of 5, and here's 4 times 3 is 12, so over 2 to the power of 12, which is the same as 2 to the power of 5. If I write that out as a division, then I'll be able to just do 5 minus 12, which is the same as 2 to the power of minus 7. So that's it as a power of 2, that fraction, 2 to the power of minus 7. Question 12. Looks like a probability question being set up here. There are 9 counters in a box. 4 of the counters are red, 2 of the counters are blue, 3 of the counters are yellow. Pavinder takes at random 2 counters from the box. Work out the probability that he takes at least 1 yellow counter. So, the way he could do this involves setting up a tree diagram, but there are 3 possibilities at the start. So, first counter could be red, or blue, or yellow. And probability of red is 4/9, probability of blue is 2/9, and probability of yellow is 3/9. I'm going to leave them as ninths, even though that simplifies to a third, because my further calculations will need to have the same denominators. So, first one, second, again, I'm just going to write down the one that I'm interested in here. So, at least 1 yellow counter. If the second one is yellow, then he's got at least 1 yellow counter. Probability of him picking yellow after having picked red is 3, because he hasn't picked yellow yet, out of the remaining 8 counters, because he has picked one of the counters overall, so there are only 8 remaining. Blue is if he's then picking yellow after blue. We've obviously got some other options here, but I'm not interested in them. And same here, but I'm not interested in them because both of those would lead to situations where he hadn't picked up a yellow counter. So blue and then yellow. Again, 3 yellow ones left out of 8. And yellow, he's already got 1 yellow, so any of the remaining 3 from here will work. I can actually, in this case, just use 3/9, but to go through the process as we normally would, red, blue, yellow. So this would be, after taking a yellow one, probability of picking red is 4 out of the 8. Probability of picking blue at this point is 2 out of the 8. And probability of picking yellow is the remaining 2 yellow ones out of 8. So I now need to multiply these and add those probabilities together. So 4/9 times 3/8 is 12 over 8/9, which is 72. 2 times 3 is 6. 8 times 9 is 72. 3 times 4 is 12. 8 times 9 is 72. And again, 3 times 2, 6 72s. And 3 times 2 is 6 72s. If I add all these numerators together, I've got 12 plus 12 is 24. So I'm going to write out 12 plus 6 plus 12 plus 6 plus 6 all over 72, which equals 24, 30, 42 over 72, which can be simplified because I can divide top and bottom by 2. So that is 21 over 36. Actually, that can be simplified again because both are multiples of 3, so that is the same as 7 over 12, 7/12. And that was a 4-mark question. So I did an appropriate amount of work for that question. Question 13, simplify this algebraic fraction fully. Always with these, factorize first. That's always the rule with algebraic fractions, because if you don't factorize first, you'll just get yourself into very complicated situations. In this case, it's pretty much the only thing you can do is factorize anyway. So first of all, I've got to deal with this numerator. But actually, before I do that, I'm going to look at that. So I said first of all, I didn't mean first of all at all. I've got to factorize this. This is an easy thing to factorize if I spot that it is the difference of 2 squares. X squared is a square, and 9 is a square, and the minus is the difference between them. Difference of 2 squares means that the denominator can be written as x plus 3, x minus 3. And that would expand as x squared plus 3x minus 3x minus 9, which is the same as x squared minus 9. So this has factorized here. Because I've been asked to simplify this fully, I expect x plus 3 or x minus 3 to be a factor of this here. So now I just have to check the numbers involved. If I hadn't done this first, the denominator, I would have had to go through quite a lot of different options here. But as it is, I'm looking for a 3 and a 1 to be at the end of my brackets. And I need to look for things that are going to end up with minus 7. So 3 times 2 gives me 6, and an extra 1 gives me 7. I need to make sure that those are all negative, though. So that's 2x minus 1 and x minus 3. That will give me 2x squared minus 6x minus 1x plus 3. So that's the correct factorization there. Cancel the common factors. So the simplified version is 2x minus 1 over x plus 3. And I can't simplify that any further, because I can't factorize the top any further, and I can't factorize the bottom any further. Just put that on my answer line, 2x minus 1, x plus 3. Question 14, work out 2 plus root 3 times by 2 minus root 3 in its simplest form. So this is similar to the last problem in that when I expand these difference of two things, the middle terms are going to disappear, but we'll have a look and see how that happens. So first things in the brackets, if I'm going to use firsts, outsides, insides, lasts, 2 times 2 is 4. Outsides, 2 times minus root 3 is minus 2 root 3. Insides, plus 2 root 3. And lasts, root 3 times by minus root 3 is the same as minus 3. The root 3's turn into a 3, and there's a minus sign in front of that. So plus 2 root 3 minus 2 root 3, those cancel each other out, and I'm just left with 4 minus 3, which equals 1. So the answer to that is just 1, the number. Question 15, vectors question. OAB is a triangle. M is the midpoint of OA. N is the midpoint of OB. And OM normally has an arrow on top. OM is this vector M. ON is the vector N. Show that AB is parallel to MN. So if I just draw in what MN looks like in here, and we're saying that line AB is parallel to MN. So I need to work out a vector for AB and a vector for MN and show that one is a multiple of the other. So I'm going to start off by saying mn equals, and to get from n to n, I've got to go via O, because I don't know this vector in here. So that's minus m plus n, going backwards on m and forwards on n. Minus m plus n, which equals, I suppose, in a neater form, it's easier to write, n minus m. AB is same thing going on. If this is the midpoint, if m is the midpoint of this line, in order to get from A to O, I'd have to go back 2m minus 2m, and I'd have to go, if n is the midpoint, again I'd have to go n and n again, so plus 2n, which equals 2n minus 2m. And I can factorize that to make sure it's clear. So the fact that these are the same in the brackets, that AB is 2 lots of mn. So I can say, therefore, so the lines are parallel, because they both contain the same ratio of vectors. Question 16. A, B, C and D are points on the circumference of a circle, centre O. As soon as I hear that they're all points on the circumference of a circle, I'm thinking of a cyclic quadrilateral, which is one of my circle theorems, and I know that opposite angles in a cyclic quadrilateral add up to 180 degrees. Angle AOC equals y. Find the size of angle ABC in terms of y. Give a reason for each stage of your working. Well, I can use the second circle theorem in here. If that's y, this must be half y, because of the circle theorem that tells us that angles at the center. I'm just going to write this as I go. Angle AOC equals y. Angle ADC equals y over 2. And justify it with, because angle at the center is twice the angle at the circumference. Or double the angle at the circumference, however you want to say that. And then ABC is going to be 180 minus that, because of this cyclic quadrilateral rule. 80 minus y over 2. Angle ABC equals 180 minus y over 2. And there's nothing I can do to simplify that. That is the angle ABC in terms of y. My justification is because opposite angles in a cyclic quadrilateral add to 180 degrees. The 4 marks there will go for the 2 calculations and the 2 explanations of the use of the circle theorems. Question 17. This is a sketch of the curve with the equation y equals f of x, so we don't know what this function is yet. The only minimum point of the curve is at p, 3 minus 4. Write down the coordinates of the minimum point of the curve with the equation y equals f of x minus 2. Well, the minus 2 in the brackets means that affects the horizontal position of the graph, because it's inside the brackets, and it has the opposite effect of what you might expect. It moves it 2 to the right. 2 places to the right. So the coordinates of the minimum point are still going to be at -4 in terms of the x direction, but the graph will have moved across 2, so it'll now be at 5 minus 4. Write down the coordinates of the minimum point of the curve with the equation y equals f of x plus 5 in brackets plus 6. So this has been, we've got 2 functions to consider here, 2 changes to consider here. This is moving it 5 to the left, and this outside the brackets is affecting the y coordinate, so this is moving it 6 up. So if I look at these and I think of 5 to the left of the point 3 is -2, 3 minus 5 is -2, and this is -4, but it's 6 higher than -4, so -4 plus 6 equals 2, so my coordinates are 2, -2, 2. Effectively, that graph would look like it's moved 5 left and 6 up, so it's moved somewhere over here. Question 18. AE is parallel to CD as marked with the arrows. ABD and EBC are straight lines, so they're just going straight through those points there. Prove that triangle ABE is similar to triangle DBC. Give reasons for each stage of your proof. Each stage of your proof. So in this, we're going to need to show that either we know that angle, side, angle are the same, or side, angle, side are the same, or side, side, side are the same, or that it's a right-angled triangle where we know the hypotenuse and a side. I take that back, that would all be for congruence. However, we're not trying to prove that they're congruent, they're clearly not congruent, so that was a silly mistake to make. To prove that they're similar, I need to prove that all of the angles are the same, because that's what's true about similar triangles. So I need to prove that those angles are the same, and that these angles are also the same, and that these angles are also the same. So firstly, I can use these ones because this is a simple rule to give. Angle ABE equals angle CBD, because vertically opposite angles are equal. Then I can use angles on parallel lines. AEB, angle AEB equals angle BCD, and that's alternate angles on parallel lines are equal. And then we've got the third angle to consider, EAB. Angle EAB equals the angle here, BDC. And it's the same reason, alternate angles on parallel lines are equal. And now finally, we can say that, therefore, all 3 angles are equal. All 3 angles of, let's be very clear about this, of ABE are equal to angles in DBC. Therefore, the triangles are similar. Question 19. The diagram shows a sketch of the curve y equals sine x for 0 to 360 degrees. The exact value of sine of 60 degrees is root 3 over 2. So that tells me that if I look at 60 degrees, which is around here, and do a vertical line there, that reading there is root 3 over 2. Write down the exact value of sine 120. Well, sine 120 is 30 degrees on from 90. So if I think about this, dividing this into thirds, that's 120, that's 150. And this is at 60, which is 30 degrees less than 90. And this graph is symmetrical. So by the time I get to 120, I'm going to get exactly the same reading across there as I did when I did sine of 60. So in fact, it's exactly the same thing. Root 3 over 2. Then asks me sine 240. Sine 240, if I keep on dividing things into 30-degree chunks, the next thing after 180 is 210, and then it'll be 240. And this graph, because the graph is exactly the same, but now it goes under the x-axis, this reading here is in the same position, but now negative. So if I read that off there, it's exactly the same as this one, but it's the negative version. So using that symmetry of the graph, sine 240 is minus root 3 over 2. Question B, on the grid below, sketch the graph of y equals sine of 2x from 0 to 360 degrees. Now if we think about this as a function, f of x, this is not 2f of x, although they've given room for everything to be doubled. It's not that, because it's not 2 sine x, it's sine of 2x. So this is in fact f of 2x. And that means that it affects the horizontal stretch. And in fact, this graph will be effectively squashed or stretched by factor half. Which means if I look at this is still the graph of sine, but it's sine of 2x. If I look at this graph, I've got to fit in double the amount of waves. If I squash that by a factor of a half, it means that instead of doing that by 360, it's going to have achieved that by 180. So instead of the peak being at 90, the peak's going to be at 45. It's going to cross at 90 instead of 180. The lowest point's going to be at 135 in here. And then it's going to go up through 180. And then the whole thing's going to happen again by the time it gets to 360. So it's not going to go any higher than 1, and it's not going to go any lower than minus 1, because the y direction is not affected here. So as I draw this in, at 45 degrees I reach the peak, at 90 degrees I'm crossing over, at minus 1 is 135 degrees, back to 180, but I've got to go all the way from 0 to 360, so I've got to do another version of the wave in there. Prove algebraically that the difference between the squares of any two consecutive integers is equal to the sum of these two integers. So let's break that down into a mathematical statement. So prove algebraically that the difference between the squares of any two consecutive integers. Two consecutive integers would be, for example, n and n plus 1, where n is any integer. So the difference between the squares of those is n squared, let's say n plus 1 squared, because that's going to be larger, minus n squared. That's the difference between the squares of those two, is equal to the sum of these two integers. So what we're trying to get that is equal to n plus 1, which is 2n plus 1. So let's try that. Here is the original statement, the difference between the squares of any two consecutive integers. And I'll expand these brackets. That's n plus 1 times by n plus 1 minus n squared. That is n squared plus n plus 1 minus n squared, and that is n squared plus 2n plus 1 minus n squared, which is 2n plus 1. Let's put some equal signs here. And to just fully go back to the start with that, that is the same as n plus 1. So that shows that, well, we've proved what we need to prove, which is the sum of the two integers. I'm just going to put a statement at the start of this. Let the consecutive integers be n and n plus 1. Sketch the graph of f of x equals minus x squared minus 3x plus 5. You might think of that more being like y equals minus x squared minus 3x plus 5, showing the coordinates of the turning point and the coordinates of any intercepts with the coordinate axes. So, a lot to think about here. Firstly, because it's got a minus x squared, it's going to be a negative quadratic that goes like that, rather than the normal U-shaped parabola that we see. It's not that, it's the upside down one, because of the minus x squared. Factorizing this to find the roots, we could say 0 equals minus x squared minus 3x plus 5. And then just to find the roots, I'm just going to multiply both sides by minus 1, because I'd rather see y equals x squared, or 0 equals positive x squared rather than negative. So that gives me 0, 0 times by minus 1 is still 0, x squared plus 3x minus 5, and then factorize that. 2x's, it's got to add two numbers that add to minus 5, sorry, multiply to minus 5 and add to 3, which doesn't happen. So this in fact is not going to factorize. So instead of that, I'm going to use the completing the square method. So I'm going to turn this into, I'm going to take the minus sign outside the whole thing and have it as minus x squared plus 3x minus 5. And I'm going to write that in completed square form. So that is minus, so x plus 1.5, because, or 3/2 squared. Just going to put a big bracket over all of this. X plus, so if I'm just looking at this bit in here, take the number in front of the x, the coefficient of x, and divide it by 2, and then we have to subtract the square of it, so that's minus 9/4, and still minus 5. So that's minus, still keeping these brackets around it all, x plus 3/2 squared. That is 2.25 plus 5, so that is minus 7.25 there. I've left it in this form because this tells me the minimum, or maximum in this case, the maximum value of y. So y equals, in this case, 7.25. So minus times a minus is plus 7.25 minus x plus 3/2 squared. The maximum y can ever be then is when this part is 0. So maximum y equals 7.25. And that happens when x equals minus 3/2. So that will make that 0. But I still haven't found my roots yet, so I can go back to where I've completed the square, and set that equal to 0 to find the roots where it crosses the x-axis. So roots are where 0 equals this whole thing, and again I'm going to times both sides by -1, so 0 equals x plus 3 over 2 squared minus 7 1/4. I just got rid of that minus sign in front of the brackets there. So to solve that, 7 1/4 equals x plus 3 over 2 squared, and if I square root both sides, let's turn this back into an improper fraction. 4 7s are 28, that's 29 over 4, and square root both sides, 29 over 4 equals x plus 3 over 2, and when I square root, that gives me plus and minus root 29 over 4. When I get x on its own now, I'm going to minus 3 over 2 from both sides, minus 3 over 2, and that gives me minus 3 over 2 plus or minus root 29 over 4. I can't find the square root of 29 because it's a prime number, but I can do the square root of 4, and that's 2. So that equals x, and therefore x equals minus 3 plus or minus root 29 over 2. Can put both of those together because they're both over 2. So that gives me my answers of, I also need the y-intercept, because that will also be an intercept. So y-intercept when x is 0. When x is 0, that's minus 0 plus 5. Y equals 5. So I've now got all of the points that I need to mark to sketch this curve. So I'm going to do that here. That's my x-axis. Here's my y-axis. And I don't need to do this at all accurately, but I need to label all the points carefully. So I know that the maximum happens at 7 1/4 when x is minus 3 over 2, so that's to the left of the x-axis. It's going to look like this. Whoops. And it crosses at 5. I'm going to do that again just to make sure it looks more symmetrical than that. Not very good. So this point here, maximum at 7 1/4. Whoops, that's the y coordinate. X coordinate minus 3 over 2, 7 1/4. This crossing point is happening at 0, 5. That's the y-intercept. And these two roots of the equation are, this one's got to be x coordinate of minus 3 minus root 29 over 2. And I can't write that any more simply in a non-calculated paper. That's a surd, so in fact that is the simplest way to write it accurately anyway. And this one is at minus 3 plus root 29, or I could just say root 29 minus 3. Either way is correct, over 2. So those are those. I could, I suppose, put the y coordinates in as well. So I'll do that, comma 0, and in that case also comma 0. And appropriately, that is the end of the test, because that was a very difficult final question there. If it had been an easier quadratic, perhaps without the minus sign, that would have made the whole thing an easier question. But as it was, finding the roots was very complicated and involved quite a lot of fraction work and surds there. So, complicated question. I would hope that most people would be able to have got at least the y-intercept and the fact that the graph looked like that. And then if you're very confident with completing the square, perhaps you could have used the formula there. In fact, I'm going to try that now underneath. So if I've got minus x squared minus 3x plus 5, we'll have a look at what that gives us. Minus x squared, is it minus 3x? Minus 3x plus 5. And we use the formula with that. That's a is minus 1, b is minus 3, and c is plus 5. And I use the formula with that. X equals minus b, so that's 3, plus or minus the square root of b squared, so minus 3 squared, minus 4ac. So 4 times minus 1 is a, times c is 5, all over 2a. So 2 times minus 1. Just make sure I've got that right. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So when I do that, again, a non-calculated paper, so I do have to do all of this in my head, but it's not too difficult. 3 plus or minus 3 squared is 9. Minus 4 times minus 1 is plus 4 times 5, which is plus 20, over minus 2. So that gives us the minus 3 bit, plus or minus root 29 over 2. And that may well be the easier way to find the roots. The reason I didn't do that straight away is because I'd already done the completing the square here in order to find the maximum point. But if you hadn't done that and weren't sure about doing that, you could have picked up extra marks by finding the two roots here and marking them on your diagram. So that would have given you most of the marks even if you hadn't got to the maximum point here. Another way of finding the maximum, having got these 2 points, would be to have found the place exactly halfway between them, which is minus 3 over 2 in this case, and then sub that into the equation to find what the y value is at that point. That would also work. So that's the end of the paper. I hope that's been useful. If you have comments or questions, you can put them below. And I will also be doing the third or second, whichever paper I haven't done from set 3, and putting that online as a video as well.